factorials. Okay, so let's go on. Um, Now, like basically, factorials is a mathematical operation used in combinatorics. We use them mostly for your level in binomial expansions. Okay, we need to calculate the binomial coefficient, so you will know more about it in time. So basically, it's multiplication of numbers in the form 0 factorial. So like 0 factorial is always 1. Okay, always 1, which is what we have here. 1, this is an exclamation mark. Factorial is always 1 to both of them. So in a CBT, if you're asked if given 0 factorial, and they say 0 factorial is A, 0, B, 1, C, 2, D, 5. What would be the correct answer? It's always 1, so the answer must be B, okay? So you must remember that. 1 factorial is 1. 2 factorial is 2. How? 2 factorial is same as 2 times 1, okay? So 3 factorial is going to be 3 times 2 times 1. 4 factorial would definitely be 4 times 3 times 2 times 1. Note that they are decreasing by subtracting 1, 1, 1, multiplying the numbers, right? And that you can also write 4 factorial as 4 times 3 factorial because this here is same as here, right? Which means I can also write 4 factorial as 4 times 3 times 2 factorial because what we have here is same as here, okay? So different ways of writing it, but maintaining the values, right? So if you notice this reducing by 1, what then is n factorial? So what then is n factorial? N factorial definitely would be n times, so reducing it keeps reducing by 1, right? Minus 1 times n. If you subtracted 1 before, you must subtract 2 now. You must subtract 3 next. And you keep reducing it. Reducing, it keeps multiplying till it gets to 3 times 2 times 1, which is what you can see right here. Okay. And the remaining simplification is simply what we had done before. Because if all of this is multiplication for n minus 1, it means if I put factorial here, I can remove all of this. And I'll get the same value, right? It's the same as n times n minus 1 factorized is what I wrote here. Okay, what I typed here. Same also all the way down. Okay, let's move to the next slide. Now, like I said before, it plays a vital role in binomial calculation of the binomial coefficient, which is part and parcel of the binomial expansion. And in particular, the binomial coefficient is written as n combination k. It could also be written this way. So these two ways are the ways we write them. So if you see this during your CBT or during your exams, it's not different from this. It's the same thing, simply meaning n combination k, where n represents the total number of items and k represents the number of items to choose from, okay, or to choose out of the n number of items you have. Okay, so the binomial coefficient itself, this is its formula. So if you have n combination k, it is simply saying n factorial all over k factorial bracket n minus k factorial. Okay, that's what you're seeing here. So if I'm going to compare that, if I give you this, now we know n is the total number of items you have, and you're choosing k. If I happen to have 4 items, and I want you to choose 2 items. The formula is saying that you should solve for 4 factorial because my n is now 4 and my k is 2. So that will be 2 factorial into 4 minus 2 factorial. So that's what the formula is saying. You know how to get 4 factorial already. You know how to get 2 factorial. So let's move forward and see how this is applied, okay? Let's see it solved. So we have some examples to solve here. So we're taught to evaluate 4 combination 3. So to evaluate 4 combination 3, you need to remember that this is the binomial coefficient, right? And that this is its formula. So you mustn't forget that. You need to remember that n combination k is always n factorial over k factorial into n minus k factorial. So in our case, we're told to evaluate this. N is 4 and k is 3. So you just substitute straight into this equation, wherever you see n, wherever you see k. Okay, so n is 4, k is 3, so my n factorial is now 4 factorial, k factorial is 3 factorial, and n minus k is going to be 4 minus 3, right? So if you do your normal math, the math you know from secondary school, or the one I just taught us just now, 4 factorial is 4 times 3 factorial. So let me solve it completely on the screen. Let me not use the short method for you, for those that are still learning, because this is new to most of you. So 4 combination 3, we want to find it. And we know it's going to be 4 factorial using the binomial coefficient, right? For 3 factorial, 4 minus 3 factorial. So you want to use board maths first, right? You start with 1 in the bracket, right? That'll be 4 factorial all over 3 factorial. 4 minus 3 is 1. So we have 1 factorial. Now, I would tell students whenever I'm teaching this, I'll tell them to look at the denominator here. Which of this is bigger? 1 or 3? Definitely 3 is bigger. So I will write 4 factorial in such a way that 3 factorial will be in it. And you already know that 4 factorial, you know, is 4 times 3 times 2 times 1, right? But because 3 is bigger, that's why I'm going to stop at 3 factorial. So 4 times 3 factorial is going to be my numerator, and my 3 factorial remains there, times 1 factorial, you already know what it is, 1, right? So this 3 factorial will cancel this 3 factorial. What are we left with? That's 4 over 1, right? And 4 over 1 is what? The same as 4. So the final answer is 4. So that's the value we're looking for. Okay, so let's see. Let's look at what was solved originally. So originally, we had the question that we're to evaluate 4 combination 3, and that is a binomial coefficient. So therefore, we know the binomial coefficient formula. It says n combination k is n factorial over k factorial n minus k factorial. Okay, so with that, we're able to see that n is now 4 and k is 3. We plugged in all the values. We checked the denominator. That's why we're able to stop at express this 4 factorial as 4 times 3 factorial, because the bigger of the two denominator values is 3. And so by the time you cancel out the 3 factorial, you'll be left with 4 over 1, and the final answer is 4. Okay, you can also try this one yourself and confirm that the solution gotten here is correct. Thank you.